To begin, bond the mirrors according to procedure AF0035665. Align the mirror connector to the bracket by loosening the locking screws. Make sure to align the bracket to the notch as shown here. Note, misalignment may damage the mirrors once the driver initiates the motors. Tighten the screws to secure the bracket. Next, connect the motor to the assembly. Take care to not damage the mirrors as it is inserted. Secure the motor using 2 screws and Loctite 242. Connect the second motor to the assembly. Take care to not damage the mirrors as it is inserted. Secure the motor using 2 screws and Loctite 242. Next, assemble the harness. Take care when handling the harness. It has delicate connections, and damaging it must be avoided. Carefully insert the connector into the hole and tighten it with a dedicated nut. Attach the connector J1 to the top motor connector and J2 to the bottom motor connector. Using 3 spacers and 3 screws, secure the board MM1021830 on the cover of the assembly. Now, for the next part of this process, we will turn our attention to the calibration target. To begin calibrating the target, place the reflective mirror cap over the target and securely fasten it by tightening the screws. The laser point will appear on the target. Move the point by mechanically adjusting the galvanometer knobs. Vertical adjustment is done with the upper galvanometer. Horizontal adjustment is done with the lower galvanometer. Adjust the laser so it hits the target area precisely in the center. Once centered, remove the reflective mirror cap. Step in this process is the mechanical zero calibration of the DeepFX scanner. Secure the 2 fixtures for assembly. Note the orientation flat on the mount fixture. Orient it to accept the corresponding flat in the assembly socket. Make sure the pin is inserted into the hole to secure it properly. Tighten the nut to secure the mount fixture in place. Connect the reflective mirror cap to the assembly. Connect the scanner driver TA1051360. Connect the assembly to the scanner fixture. Now we can calibrate the mirror motors so the beam will hit the target center when the assembly is rotated on the target jig and the drift of the beam remains centered and within a 10 mm diameter around the target center. By adjusting the motor knobs, we will align the laser beam with the axis of rotation of the assembly as it is rotated on the target fixture. This axis is effectively the zero direction we calibrate to. To achieve this, we have 2 sets of knobs, the galvanometer knobs on the target, used to move the position of the laser across the target, but will not affect its calibration. And the motor knobs, one mounted on each motor of the assembly, which allow for the calibration of the mirrors. This calibration will correct the misalignment of the mirror's motor and align the laser beam to the axis of rotation, that is the zero direction. When calibrating, remember to rotate the assembly periodically to check your progress. If at first you can't see the laser path on the target, adjust the motor knobs to bring the laser path onto the target. Open the locking screws to find the desired friction level. If needed, use a torque wrench. Then adjust the motor knobs until the drift orbit is smaller than the gray circle at the center of the target. Rotate the assembly periodically to check your progress. Use both sets of knobs carefully to bring the laser drift to be as small as possible and centered and inside the gray area at the center of the target. Once a drift of less than 10 mm in diameter has been achieved, you can continue the process. Secure the motor's locking screws. This may affect the calibration, and the second phase of rotating the module on the target should be performed to verify that the laser remains centered on the target. If any adjustments are required, you must open the locking screws and repeat the calibration process until the laser dot drifts inside the target center while rotating the assembly and the locking screws are secured. Once calibration has been achieved, You can continue.